Okay, guys, I just wanted to go over today's live lesson really quickly with you. I wanted to go through and shorten everything so that it fits within a time frame that I know that you would watch. So today we're talking about ratios and rates, and these are the three objectives for today. I will use a multiplication statement to describe two quantities as a ratio. I will identify unit rates and the difference between rates and unit rates. And I will identify and reason with ratios, including unit rate and ratios in a given context. Okay, so the first thing I want you to do is look at the visual that we have provided. We are comparing children and adults, and I want you to think for a second what you noticed and what you wonder. All right, I'm going to keep talking just for the interest of time. I see that we have 2 boxes for children compared to the 3 boxes for adults. I see that the 2 boxes for children represent 140. If the 2 boxes for children represent 140, then I would imagine that each of the boxes would be worth 70. And I can see that the children and the adult boxes are both equal amounts, or the same size. So I could determine that this is 70, this is 70, and this is 70, okay? Then if I go to think I need a total for the adults, well, 70 plus 70 plus 70, or 70 times 3, is 210. So for the children, I have 140 compared to the adults of 210. All right, so for ratios, it's a comparison of 2 quantities. And there are a couple of different ways to write ratios. You can write them as a fraction. So when we think back to the last page, we had 2 boxes compared to 3 boxes. So we could write that as 2/3, or 140 over 210. You can also write it as a statement with a colon in the middle. So A to B, 2 to 3, and 140 to 210. Okay, then you can write them as with the word to, T-O, in the middle. A to B, 2 to 3, 140 to 10. Okay, so those are the 3 different ways that we can write ratios. All right, so we're going to work with ratios on this next slide. We are going to write a ratio of the green to red triangle. So I see that I have 1, 2, 3, 4 green triangles. And I have 1, 2, 3, 4, 5, 6 green triangles. So I can write that 4 to 6, 4 to 6, or 4 to 6. Okay. On this next statement, I'm going to compare my red to my green. So this time I would have 6 to 4, 6 to 4, 6 to 4. And lastly, on that last box, I'm going to do my green to all my triangles. So I have 4 greens to 10 triangles. I can write that 4 to 10, or 4 to 10. Okay, so those are the different ways that I can write the ratios represented in this problem. All right, let's keep going. So for this one, it says working with ratios. So for every 2 purple, there are 3 pink. So you're going to have to bear with me because I'm kind of limited in my choices here. So I'm going to say for every 2 purple, there are 3 pink. And our pink for this is going to be red because that's the option that we have with our color choices. Okay, for the next one, the ratio of purple to pink is 5 to 3. So for this next ratio, I'm going to have 5 purple. Okay, and I'm going to have 3 red. And Miss Brown just realized that she could use the star at the top of her screen and not have to use the colors. So let's do this really quickly. I'm going to have 2 purple to 3 pink. Okay, on this one I'm going to have 5 purple to 3 pink. All right, on my next ratio, I have 3 out of 4 are pink. So I'm going to have 3 that are pink out of 4 total. So 1, 2, 3, 4. All right, and 2/3 are purple. So I'm gonna have 2/3 means 3 out of 3 that are purple. So those are the ways that I would represent those ratios. All right, let's keep looking. All right, on this slide, they're asking for us to use mental math strategies to determine the ratios that we have in this visual. So we have a number of packs and the number of sticks in each pack. Well, if I know that one pack has 17 sticks, okay, so I'm gonna look for some relationships that I know. I know that 2 packs, so 1 times 2 is 2, and 17 times 2 is 34. So I'm gonna have 2 packs with 34 sticks in each pack. If I continue to use mental math, I know that 2 times 2 is 4, okay? So 34 times 2, or 34 plus 34, is 68, okay? I can keep going with my mental math. I know that 4 times 5 is 20. So 68 times 5 is going to be 340, okay? From here, I could decide to use some division, or I could say, well, if I go back to my original pack, 1 times 5 is 5. So if I look at this original amount, 17 times 5 would give me 85. Okay, so from here I can go to 5 times 3 is 15. Well, 85 times 3 is going to give me 255. Then I have this really awesome number at the end. It's going to take a little bit more of my brain power. So I know that there are going to be 153 sticks. I need to know how many packs I would have. Well, if I did 17 times 9, I'm going to do a really big jump right here, times 9, that would give me 153. So 1 times 9 would give me 9. So I went back to that original ratio that I had of 1 out of 17 to figure out the answer for that one. So in 9 packs, there are going to be 153 sticks. Clear all this work off right here. Go on to the next one. All right, just for the interest of time, I'm going to skip to slide number 12 because we're kind of repeating ourselves a couple of times here. All right, so these are some examples from Imagine Math. Charlotte is going to run a 10-kilometer race. She is trained to run 1 kilometer for every 4 minutes. So we're comparing for these 2 different quantities. So in this case, we are talking about a rate. So a ratio is a comparison of 2 different amounts, okay? A rate compares 2 different quantities. So for this one, we know that we can, that Charlotte's gonna run 1 kilometer for every 4 minutes. So the 2 things that we're comparing are kilometers and minutes, okay? We want to know if she runs at this rate, which of the following statements is true? So I need to look at the relationship that I can see. So I built my table and I said kilometers over minutes. So for every 1 kilometer, we run 4 minutes. I need to know the rate that she can run in 20 minutes. So, or how many kilometers she can run in 20 minutes. So we're gonna look at the relationship that we see. So we know that 4 times 5 is going to be 20. Well, we're going to do the same thing to the top. So 1 times 5 would be 5. Okay, so we're going to run in 20 minutes, we could run 5 kilometers. Okay, so we need to look and see which ones of the bottom choices are true. After she runs at this rate for 20 minutes, which statement is true? Okay. She will have completed half of the race. Well, let's look at this choice, okay? We have done 5 kilometers. The entire race was 10 kilometers. Is 5 half of 10? Yes. So we're going to put a check mark by this answer, okay? Let's look at this next choice. She will have completed 1/5 of the race. Well, 1/5 is equal to 2 kilometers, okay? We have 5 kilometers. That is not what's happening here. She will have finished the race. Well, the race was 10 kilometers, okay? We have only gone 5, so this is not a correct answer choice. She will have completed 1/3 of the race. Well, 1/3 of the race is 3.3. We have gone 5 kilometers, so this is not the correct answer choice. So if she has gone 5 kilometers at a rate of 20 minutes, at a rate of 4 kilometers per minute, and she's gone for 20 minutes, she has run half of the race. Okay, let's keep going. Be clear, okay. Enzo uses a hose to fill a 225-gallon pool with water. Water fills the pool at a constant rate of 15 gallons per minute. So again, we're comparing two different things, gallons and minutes. So we know that we can go, she can fill 15 gallons in 1 minute. So now we need to determine the relationship here. So if I multiply 15, I believe it's by 15, I would get 225. Let me just check my work really quickly. Yes. Okay. So we are going to see this relationship. 15 times 15 will give me 225. So 1 times 15 will give me 15. Okay, so I'm going to keep using my ratio table, and I'm going to try to figure out, with the given information, which statement is a reasonable conclusion. Okay, so my first answer choice has me dealing with 20 minutes. And we want to figure out how many gallons are in the pool after 20 minutes. Okay, so I'm going to go back to my original ratio table, and I'm going to look for a relationship that I know. Okay, well, I know, and let me change colors here so it'll be a little bit easier to see. I know that 1 times 20 will give me 20. So whatever I do on the bottom, I must also do on the top. 15 times 20 is going to give me 300. Okay, so there will be 300 gallons in the pool after 20 minutes. Well, that happens to be true, so I'm going to go ahead and I'm going to give this statement a green check. Okay, there will be 75 gallons in the pool after 10 minutes. Okay, so here's that representation. And again, I'm going to switch colors so it can make it a little bit easier to see. I know that 1 times 10, oops, sorry, I didn't switch back to my pen. I know that 1 times 10 is 10. So 15 times 10 is going to be 150, okay? So in 10 minutes, there are going to be 150 gallons, okay? So I'm going to give this answer choice an X because it will be 150 and not 75. Okay, the pool will be 1/3 full in 1/3 of an hour. Ooh, okay, let's come back to that bad boy. That's gonna take a little bit more of our brain power. Okay, the pool will be 1/3 full in 5 minutes. Okay, so let's look at this. In 5 minutes, I have, let's look for a relationship again that I see here in my table. 1, oh, and I didn't switch to my pen again. 1 times 5 is 5. So 15 times 5 is going to be 75. Okay, I need to figure out if that is 1/3 full in 5 minutes. Well, if I do 225 divided by 3, that's going to give me 75. So, is my pool 1/3 full in 5 minutes? Yes, it is. I have 2 checks. I need to go. Let me see. All right. The pool will be 1/3 full in 1/3 of an hour. Okay. So, if I'm talking about an hour is 60 minutes, right? 60 minutes divided by 3 is 20 minutes, okay? In 20 minutes, we've already established that it's going to be $300.